Good day once again. So now we are going to learn how to solve quadratic inequality in one variable. But first, let us differentiate a quadratic equation from quadratic inequality. What is the difference between quadratic equation and quadratic inequality? Yes, when we say quadratic equation in one variable, it is a mathematical sentence of degree 2 that can be written in the standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. While quadratic inequality is an inequality that contains a polynomial degree 2 and can be written in any of the following forms. So we have ax squared plus bx plus c is greater than 0, ax squared plus bx plus c is less than 0, ax squared plus bx plus c is greater than or equal to 0, and ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers and a is not equal to 0. So basically, the difference between a quadratic equation from a quadratic inequality is by the use of the inequality symbol. So when we say quadratic equation, it makes use of an equal sign or an equal symbol, while for quadratic inequality, it makes use of greater than, less than, greater than or equal to, and less than or equal to symbols. Quadratic inequalities are solved either by the use of the graphic or algebraic method. So to solve algebraically, we follow these steps. So first, we turn the quadratic inequality into an equation. So we are going to change the inequality symbol that is used into an equal sign. Then, we find the solutions. Once we find the solutions, we need to make a number line and plot the solutions using an open or closed dot based on the original inequality symbol. If the inequality symbol that is used is greater than or a less than symbol, we use an open circle or a hollow circle. But if the inequality symbol that is used is greater than or equal or less than or equal to symbol, then we make use of a closed dot or a solid circle. So based on the number line, once you plotted the points, we can see that the number line is divided into 3 regions. We are going to choose a test point or test value in each interval to see if the interval satisfies the inequality or not. If the test value produces a true statement, the entire interval will be true. If the test value produces a false statement, the entire interval is false. And lastly, we check each solution and interval. So let us watch a short clip for our examples.
Okay, so let us determine the solution set of the given quadratic inequality x squared minus 2x minus 3 is greater than 0. Okay, so remember the steps in solving for the solution set of the quadratic inequality is to turn the inequality into an equation. So therefore, we are going to change the inequality symbol to equal sign. So we have x squared minus 2x minus 3 is equal to 0. So after that, we are now going to find the solution. So we can make use of either of the 4 solutions or 4 methods of solving quadratic equation that we have previously discussed. So, depende kung ano yung applicable dun sa particular quadratic equation. Okay? So, in this case, pwede nating i-factor since the equation itself is factorable. So, we are going to have x squared minus 2x minus 3. So, the factor of this trinomial would be x minus 3 times x plus 1. Okay? So, next is for us to solve the resulting linear equation by applying the ZPP or the zero product property. So we have x minus 3 is equal to 0. Then we also have x plus 1 is equal to 0. So therefore, our first value would be 3 and our second value would be negative 1. So, itong na-solve nating values ng x, yung solutions na na-solve natin, i-plot natin ngayon sa number line. Okay, so we need to draw our number line and plot these points. Take note that if we are going to plot the points, i-consider natin kung ano yung inequality symbol na ginamit dun sa original inequality. So, take note that if the inequality symbol that is used is greater than, okay, greater than, or less than symbol ang ginamit, okay, then ang points natin, we are going to make use of an open circle or a hollow circle. So, pag greater than or less than yung symbol na ginamit, iplot natin yung points by using an open circle or a hollow circle. Pero pag greater or equal or less than or equal to symbol yung ginamit na inequality, we are going to make use of a hollow circle or a solid circle. Okay? Okay, so ito na yung number line natin. I-plot natin yung na-solve nating value ng x. So, therefore, we have x is equal to negative 1 and positive 3. So, since ang inequality symbol na ginamit is greater than symbol, we are going to make use of an open circle or a hollow circle to plot the points. Okay, so there you go. So, since na-plot na natin yung points, if you're going to observe, nahati ngayon yung number line natin into 3 regions. So, yung first region is the region going to the left. Okay? O yung region kung saan yung mga values o yung mga intervals natin is negative. Less than negative 1. Okay? Yung second region natin is the region in between negative 1 and positive 3 intervals. Okay? Then, yung third region natin is going to the right. Okay? Or yung interval which is equal to greater than positive 3. So, all the numbers going to positive infinity. Okay? So, from there, kukuha tayo ng representative ng bawat region. We are going to identify or select our test points or our test value. So, dapat well represented yung number line natin. So, dito sa side na to, so dito sa region na to, let us have negative 2. Dito sa middle region, or yung region in between negative 1 and positive 3, let us just use 0. And then, dito sa region to positive infinity, okay, or to sa region which are greater than positive 3, let us use 4. Okay? So, itong test point or test value na choose natin, isa-substitute natin ngayon sa original equation. Titignan natin kung yung test value magproproduce siya ng true statement. Otherwise, kung false yung statement, ibig sabihin yung region kung saan galing yung test point natin is not part of the solution set. Pero kung true, okay, ibig sabihin yung region na to or region na yun kung saan galing yung test point na kinuha natin, kung saan siya nag-true, kung halimbawa true siya, ibig sabihin yung region na yon is a part of the solution set. Okay? So, let us check our test points if they are going to produce a true or a false mathematical statement. So, our original inequality is x squared minus 2x minus 3 is greater than 0. So, if x is equal to negative 2, so therefore we have to change all the x's by negative 2. So we have negative 2 square minus 2 times negative 2 minus 3, is it greater than 0? Okay, so negative 2 square is 4. Negative 2 times negative 2 is positive 4 minus 3. Is it greater than 0? So 4 plus 4 is 8. Minus 3 is 5. Is 5 greater than 0? Yes. So, it is a true mathematical statement. So, ibig sabihin, yung test value natin na negative 2 is a part of the solution set. And negative 2 is a representative of this region. So, ibig sabihin, isi-shade natin itong part na to ng number line natin. So, ibig sabihin, yung solution set natin, ito yung part kung saan part siya ng solution set. Okay? Ito yung region doon sa number line natin kung saan part siya ng solution set. Okay? Take note, hindi kasama yung negative 1. So, whether we are going to make use of negative 3 or negative 4 or negative 10 or negative 100, the mathematical statement that we are going to produce, if we are going to substitute that to our original inequality, is a true mathematical statement. Okay? Next. Let us use if x is equal to 0. So, etong test point natin or test value natin is a representative of the middle region or the region wherein it is in between negative 1 and positive 3. So, again, we are going to change all the x's by 0. So, we have 0 square minus 2 times 0 minus 3 is greater than 0. So, 0 square is 0, negative 2 times 0 is 0, so 0 minus 3 is negative 3. And negative 3 is not equal to 0. So, negative 3 is not greater than rather to 0. So, ibig sabihin, false yung mathematical statement. Ibig sabihin, hindi part ng solution set natin si 0. Okay? Or yung region na nire-represent ni 0, hindi siya part ng solution set. Okay? So, hindi natin isi-shade yung number line kung saan makikita yung 0. Okay? Let us have if x is equal to 4. Yung pangatlong region natin or yung region that represents the numbers which are greater than positive 3. Okay, so we change all the x by 4. So we have 4 square minus 2 times 4 minus 3. Is it greater than 0? Okay, so therefore 4 square is 16. Negative 2 times 4 is negative 8 minus 3. Is it greater than 0? 16 minus 8 is, yes, 8 minus 3 is 5. So, is 5 greater than 0? Yes, very good. So, it is a true mathematical statement. So, ibig sabihin, yung region na nire-represent ni 4 is a part of the solution set. And since 4 is a part of the solution set, ibig sabihin, i-shade natin itong region na to. Yung region na nire-represent ni 4. O yung region which is greater than positive 4. So, yan yung graph ng solution set natin. Ibig sabihin, yung solution set natin, hindi kasama yung negative 1, 0, 1, 2, and 3. These numbers are not part of our solution set. So, if you're going to write our solution set, so our solution set would be the set of all x such that x is less than negative 1 but greater than positive 3. So, ito na yung solution set natin. Okay? Okay, now we are going to try x squared minus 5x minus 14 is less than or equal to 0. So, katulad ng ginawa natin kanina, we are going to change the inequality symbol to equal sign to turn it into an equation. So, we are going to have x squared minus 5x minus 14 is equal to 0. Then, we are going to solve for the solution. Okay? So, therefore, pwede siya by factoring. So, i-factoring natin. So, therefore, we have x minus 7 times x plus 2. Okay? So, apply the ZPP. So, we are going to have x minus 7 is equal to 0. So, therefore, x is equal to positive 7. Then, we have x plus 2, yung isang factor natin, is equal to 0. So, therefore, x is equal to negative 2. So, again, ipla-plot natin itong points na to sa number line. So, we are going to plot 7 and negative 2 on the number line. And since ang inequality symbol natin is less than or equal, we are going to use a solid circle or a closed circle. So, we have negative 2, shade natin to close it, and positive 7. Okay? So, nahati sa tatlong region yung number line natin, kukuha tayo ng representative from each region. So, let us have our test points or test value. Some refer test value or test points as the critical points. So, we have here numbers that are less than negative 2. So, let us use negative 3. Sa middle region or region in between negative 2 and positive 7, let us use 0. And the region that represents the numbers which are greater than positive 7, let us use 8. So, again, itetest natin itong test values natin whether they are going to produce a true mathematical statements or not. So, katulad ng kanina, if the mathematical statement that is produced is true, isi-shade natin kung saan galing yung or kung anong region yung nire-represent nung test point na yon. Okay? Otherwise, hindi natin isi-shade. So, if x is equal to negative 3, we're going to have negative 3 square minus 5 times negative 3 minus 14. Is it less than or equal to 0? So, negative 3 square is 9. Negative 5 times negative 3 is positive 15 minus 14. Is it less than or equal to 0? 9 plus 15 is 24 minus 14 is 10. So, is 10 less than or equal to 0? Yes, it is not. So, therefore, it is a false mathematical statement. So, yung region na nire-represent ni negative 3 is not part of the solution set. So, hindi natin kailangang i-shade yung number line natin. Okay? Next, if x is equal to, let us say, yung 8 muna. Okay? So, same process. we have 8 squared minus 5 times 8 minus 14. Is it less than or equal to 0? Okay, so 8 squared is 64. Negative 5 times 8 is negative 40. Okay, minus 14. Is it less than or equal to 0? 64 minus 40 is 24. Minus 14 is 10. And 10, again, is not less than or equal to 0 because it is greater than. So, therefore, it is a false mathematical statement. Then, let us use our third test point if x is equal to 0. So, we have 0 squared minus 5 times 0. Is it less than, or rather, minus 14, I should say. Minus 14. So, minus 14. Is it less than or equal to 0? So, 0 squared is 0. Negative 5 times 0 is 0. 0 minus 14 is negative 14. Is negative 14 less than or equal to 0? Yes, it is true. So, therefore, ibig sabihin, yung region na nire-represent ni 0 are part, or is a part rather, of the solution set. Since part siya ng solution set, at yung 0 is the middle region, isi-shade natin itong buong region na to. Yung region na nire-represent ni 0. So, we are going to shade this part. Yeah. So, ibig sabihin nito, yung solution set natin is the middle region or the numbers that are in between negative 2 and positive 7. And since close circle or close dot ang points natin, ibig sabihin, part din sila ng solution set. So, if we're going to enumerate the elements of our solution set, then, therefore, we are going to have negative 2. The solution set would be negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and 7. So, we can write our solution set as the solution set is equal to the set of all x such that x is greater than or equal to negative 2 but less than or equal to positive 7. Okay?
Okay, so let us find the solution set of x squared plus x minus 2 is less than or greater than rather 0. Then graph. Okay? So as our first step, x squared plus x minus 2 is greater than 0. What would be the first step for this? We are going to change the inequality into an equation. So basically, we are going to change this symbol, the greater than symbol, by an equal sign. Okay? Then next, what would be our step 2? We are going to solve for the solution of this quadratic equation. So we can make use of either of the 4 methods of solving quadratic equation. But of course, it depends upon the kind of quadratic equation. So in this particular equation, we can make use of the factoring method. So we are going to factor x squared plus x minus 2 is equal to 0 as x plus 2 times x minus 1 is equal to 0. So we apply the ZPP or the zero product property. We are going to set each of the factors equal to 0. So we have x plus 2 is equal to 0 and x minus 1 is equal to 0. So we can now solve for the value of x. So our first x is negative 2, while our second x is 1. Okay, then we are going to plot negative 2 and positive 1 on a number line. So since the inequality symbol that is used is greater than, our circle is an open circle or a hollow circle. So we have negative 2 and positive 1. So the number line is divided into 3 regions. We have this region less than negative 2. Then we have this region, the region in between negative 2 and positive 1, and our third region, the region which is rather greater than positive 1. So we are going to select a test point from each of the regions. So our test point would be here. If we are going to have negative 3, so it is a number which is a representative of the region which is less than negative 2. So we substitute x, which is equal to negative 3, to the original inequality. So we have negative 3 squared plus negative 3 minus 2, is it greater than 0? So we have negative 3 squared is 9 plus or positive times negative 3 is negative 3. So we have 9 minus 3 is 6 minus 2 is 4. And 4 is greater than 0, so therefore it is a true mathematical statement. Next region, the region in between negative 2 and positive 1. So let us use 0. So we have 0 squared plus 0 minus 2 is set greater than 0. So we have 0 squared is 0, minus 0, minus 2. So we have negative 2, and negative 2 is not equal to 0 because 0 is always greater than any negative number. So therefore, it is a false mathematical statement. Then we have another test point. A test point that would represent the numbers or the region which is greater than positive 1. So we choose 2. So we have 2 squared plus 2 minus 2, is it greater than 0? So 2 squared is 4 plus 2 is 6 minus 2 is 4. And 4 is greater than 0, so that means it is a true mathematical statement. So we are going to shade the part, okay, the part or the region wherein our test points produce a true mathematical statement. So we are going to shade this part and this part, okay? So we have this as our graph. So take note, you need to write or draw the arrow to indicate that the line or the number line goes on to positive infinity, while here the line or the solution set goes on up to negative infinity. Okay, so therefore the solution set is the set of all x such that x is less than negative 2 but it is greater than positive 1. Okay, so let us have another example. Find the solution set of 3x squared plus 13x minus 10 is less than or equal to 0, then graph. So what would be our first step? Yes, we have 3x squared plus 13x minus 10 is equal to 0. So we change the inequality into an equation. Then next, we are going to solve using either of the four methods of solving quadratic equation. So we can have factoring method. So the factors are 3x minus 2 times x plus 5 is equal to 0. So we apply the ZPP or the zero product property. So therefore, we have 3x minus 2 is equal to 0 and x plus 5 is equal to 0. So we solve for the resulting linear equation. So we have x is equal to negative 5. We simply transpose positive 5 to the other side. So that would be our first root or one of our points. Here we have to transpose negative 2 to the other side. So we have 3x is equal to positive 2. And then, yes, we are going to divide both sides by 3. Therefore, we are going to have 3x over 3 is equal to 2/3. So we simplify. Therefore, what would be the value of our x? Yes, we have x is equal to 2/3. So what are we going to do with 2/3 and negative 5? Yes, we are going to draw our number line and plot these points in the number line. So take note, we need to use a closed circle or a solid circle because what is the reason? Yes, because the inequality that is used is less than or equal to symbol. So take note, if the inequality that is used is less than or equal to symbol or a greater than or equal to symbol, the circle that we are going to use to plot the points should be a closed or solid circle. Otherwise, we are going to make use of an open or hollow circle. So, the number line is divided into 3 regions. So, we are going to choose a representative from each region. So, here we are going to have negative 6. We just use the closest number, okay? But if you want to make use of negative 10, then you can do so. So if x is equal to negative 6, we have to substitute negative 6 to all the x's on the original equation or original inequality rather. So we have 3 times negative 6 squared plus 13 times negative 6 minus 10 is less than or equal to 0. So we have negative 6 squared is 36 times 3, so we have 108. Then positive 13 times negative 6, we have negative 78 minus 10. So therefore, we have 20. 20 is it less than or equal to 0? Is this mathematical statement true? Yes, it is false. Of course, 20 is greater than 0. So since negative 6 produces a false mathematical statement, we cannot shade this portion. Meaning, all the numbers that are less than negative 5 to negative infinity are not part of our solution set. Okay, next, we use another test point, the middle region. A test point from our middle region or the region between negative 5 and positive 2/3. So, we use 0. Okay? So, if you want to make use of negative 1, negative 2, negative 3, or negative 4, you can also do so. But we use 0 since it is much easier if we are dealing with 0. Okay, so we have 3 times 0 square plus 13 times 0 minus 10, is it less than or equal to 0? So multiplication by 0 is 0. So therefore 0 minus 10 is negative 10. Is negative 10 less than or equal to 0? Yes, it is true. Meaning, the region which is represented by 0 are parts of the solution set. Meaning, if negative 4 is a solution of our quadratic inequality. Same is true with negative 3, negative 2, negative 1, or negative 1 half. Okay? As well as positive 1 half, of course. Okay, then the last region, the region which is greater than 2/3. So let us use 1. So if x is 1, we have 3 times 1 square plus 13 times 1 minus 10 is less than or equal to 0. So 1 square is 1 times 3 is 3. Then 13 times 1 is positive 13. So 3 times 13 is 16 minus 10, so we have 6. And 6 is not less than or equal to 0. So therefore, we produce a false mathematical statement. So therefore, our graph would look like this. So we shaded the part or the region which produces a true mathematical statement. And that region is the middle region. Okay? So therefore, our solution set is the set of all x such that x is greater than or equal to negative 4 but less than or equal to 2/3. So if we are going to enumerate the solution set, the elements of our solution set, we could have negative 4, negative 3, negative 2, negative 1, 0. Okay, we can also have 0 0.5, 0 0.25, or 1/4. Okay, so let us do some activity. So while you are doing the activity, you may opt to pause this video. Then you may resume watching once you are done solving or determining the solution set of the following quadratic inequality. Okay, so I suppose you are done. So for number 1, we have x squared plus 7x plus 12 is greater than 0. So our graph looks like this. Okay, so the solution set is the set of all x such that x is less than negative 4 but greater than negative 3. So the circle that you use should be a hollow or an open circle. Did you get it correctly? Very good. Next, let us have number 2. We have x squared plus 5x minus 6 is less than or equal to 0. So the graph looks like this. So we make use of, you should have your points plotted using a solid circle or a closed circle. And the shaded region is the middle region. Because the solution set is the set of all x such that x is greater than or equal to negative 6, but it is less than or equal to positive 1. Okay? So that ends our lesson. Thank you and God bless.